Welcome to the Human Side of Engineering and Product Development podcast, brought to you by Saratech. Hi, Mike. Welcome to the podcast. Glad you can join us today. You are currently...
Hey, Andy. Happy to be here.
Yeah. Thanks for the time. You are currently the Senior Vice President of Engineering Operation at Saratech. We're glad to have you here. You and I both work for the same company. Glad to have this chance to talk to you. Can you tell us a little bit about yourself?
Yeah, so I think of myself purely as an engineer. All my background is in engineering. My graduate degrees are all in engineering and robotics. So primarily systems engineering, mechatronic systems going way back. And then spent a number of years working for NIST and NASA and at RPI, Rensselaer Polytechnic, and robotics. And then went into more systems engineering from there and work at GE. And then from GE, went to work at Ford, which actually got me into IT. So I moved from engineering into engineering systems at Ford. And that led me further and further in IT. So I had the opportunity to be CIO at a bunch of different companies like Jaguar Land Rover and Grainger and Harman and Omega Engineering. So I did the IT CIO work for a long time and learned a lot about enterprise class systems that way. And then at Omega Engineering, I was also the head of engineering. I said I really want to get back to engineering. So this opportunity came up at Saratech to really get back and run the engineering organization, which I really enjoy. And that's what led me here. And now I'm sort of, getting back into all kinds of engineering, including systems engineering again.
That's fantastic. Now, you have obviously tons of experience in both systems engineering and also in optimization. Do you remember what got you interested in engineering? I remember for me, when I was a kid, this was back in the early 80s. I saw the movie Tron. I remember you remember the Tron movie from the 80s. And I saw that and I thought that was the coolest thing. I'm like, you know what? I really want to get into computers. I really want to get into technology. I knew it wasn't anything like that, like the movie, but it just seemed so cool to me. So that's what started my interest with, computer science and engineering, all that. Did you remember was there anything that piqued your interest?
Yeah, it's interesting. Yeah. I mean, my childhood was more the 60s and 70s, but still, it wasn't a movie. It was really just, I remember from my earliest days, I was always interested in science. I was always collecting insects and looking at stuff under a microscope. And I was very fortunate my parents fostered that interest in me in an early age. I was collecting rocks and all this stuff. So I was always going to be some kind of scientist. And when I started looking at careers and things, I originally was going to go into geology, and that led me, though, to a series of situations, led me to mechanical engineering. So I would say just since a kid, I was always interested in science and technologies, always built kits, had science kits, chemistry set, did model rocketry, you name it. I was all into science and technology.
That's great. Yeah. So you always knew in an early age, that's what you wanted to do. It wasn't, hey, this is what my parents wanted you to do. Because, as an Asian kid, a lot of time, Asian parents put a lot of pressure on the kids. You
I've heard that.
either become a doctor or you are an engineer. Those are your two choices. You don't have any other choices.
Yeah, no, my parents, my mother was a librarian and my dad worked for the government. So they didn't have a heavy science background. But like I said, once they saw I guess what helped, my mother was a librarian. So she was always able to get me all the books I wanted on different topics and stuff from whatever school library she was at, plus my school library. So I think that helped.
Oh, that's great. Now, obviously you have lots of experience in IT. Especially in the area of efficiency and optimization. You said you started out as an engineer, but then your career kind of took a different path, and then you ended up in that area. Can you tell us a little bit about that journey? How did you get into that area?
Yeah, so like I said, I was at GE and I was working in engineering. Actually, I was in charge of systems engineering at GE Appliances, and there's an opportunity that came up to go to Ford. And it was interesting. It was Ford that said, well, we want you to work in engineering systems where you'll be in charge of deploying the CAD package that Ford used worldwide. So it was, and I was like, okay, that sounds interesting. Let's give it a shot. And that was part of the IT organization. Well, I had experience in IT systems. I had a lot of Six Sigma background, which Ford was really into at the time.
Yeah.
And I had a lot of software development background and expertise. I think that was probably the thing. So moving into that organization was not a stretch. First of all, I was dealing with engineers. I mean, that was the thing. Both, we had engineers that happened to work in IT, and we interfaced with the engineers at Ford. So again, just engineers talking to engineers made it a very easy transition. And then all the work was around developing software and testing it at enterprise scale. And that was all stuff I kind of knew. So I knew how to apply process techniques and Six Sigma techniques to improve in that process. So it turned out to be a good fit. I would say Ford was wiser maybe than me and you to go, geez, really? Is that what you think he could do? And they were spot on. That job fit me like a glove. And that's how I got into it.
That's great. Now, so, obviously you've had so many years of experience. What are some of the most significant changes that you have observed in the engineering field in the past few decades?
Yeah, well, I mean, clearly the use of computers, right? I mean, I was in the last class in high school to learn how to use a slide rule, right? I think 11th grade, we were using slide rules, and 12th grade, the TI calculator came out, and everybody switched to calculators. And then when I went to college, it was just before everybody would just, nowadays, right? If you don't have a computer when you show up at school, you're in trouble. They're going to give you a laptop. They're going to figure out how to get you a laptop where you can't work. But when I got there, everybody was starting to use the IBM mainframe to do a lot of their work. And so I worked at the computer center. So the biggest change is the use of computers. I mean, like I said, I was in the transition of that. So all the stuff I learned, like doing control theory and stuff, we learned graphing techniques using paper and pencil. And literally by the time I graduated and went to grad school, you made no sense to do that. You were doing everything on the computer using MATLAB and tools like that. So I would say that is absolutely the biggest change that I've seen. It's just the ubiquitous use of computers and the power of computers. I remember when I was in grad school, there was this thing called the internet, and somebody called was it Mosaic, right? Or before it became
Al Gore invented the
right after Al Gore invented it. Yeah. Then there were a bunch of people, and Mark Andreessen's company, right? Before it became Netscape, right? I remember it was like the guy was showing me, hey, there's this tool called Mosaic, and it kind of gives you a user interface to this thing called the web. And I was like, oh, that's interesting. Wonder what people will do with that. So that has just been pretty massive. And then just the rise of computer code running everything, right? And the amount of code. When I started, we were writing on 8-bit microprocessors using, 8K of RAM. And then like literally 10 years later, I'm on 32-bit microprocessors, and the programs are just massive, right? I mean, we're buying megabytes of memory to store them and stuff. So
yeah, I remember I was at earlier in my career, I was at another company, and one of the hardware that we sold were Sun Microsystems. And I remember one of the sales rep configured a Sun server. And you got to remember, this is in the early 90s. And she said, I need to configure this with 1 gig of RAM. And I was like, what? 1 gig of RAM? What are you going to do with all that? Yeah. It's because at the time, that was like, I mean, it was incredibly expensive. That was $1 million server. With 1 gig of RAM, it's so amazing how much technology has advanced.
Yeah, and how much of an impact it's had just there. I would say that is the biggest thing, in the impact on the engineering field, where, literally, you can't do your job without a computer, right? If the computers are down, your company's down. Everything. I remember we used to talk about backup plans. If the computer's down, you could do this or that. You can't do anything now if the computer's down. Nothing. Yeah. Right. You just have to wait. You're calling to see if the computer's back up. That's it. Right. So.
Yeah, for sure. For sure. Now, speaking of computer, I think another, I guess you can call it technology or topic of advancement in the engineering field would be PDM and PLM, right? So those two concepts, they're not new concepts. They've been around forever. But I think they really took hold back in the early, maybe mid 80s, early 90s. That's when it really blew up, and PLM and PDM, became the thing, right? But one of the things that being in this industry, I have seen, and I'm sure you've seen too, is amazingly, a lot of companies are still at the very, very early stages of PDM not even PLM, PDM implementation, right? Why do you think that is?
Yeah. So, this is what I did at Ford for the first 3 or 4 years there was we did CAD, CAM, PLM, right? That was the group I was in. I think what I would say is that people underestimated just what it takes to do PLM. And I don't mean in terms of technology. I think there was maybe some underestimation in terms of technology because these are actually fairly complex database systems that you have to put together. And it takes time to learn the right data model that has to underpin all the stuff that people are doing. But, and so the technology itself can be complex, but what's more complex is that the processes, right? And the people that you're trying to now automate, the things you're automating are incredibly complex. So if you think about it, right, the PLM system is really trying to automate all your processes around product development. And those aren't simple processes, right? I mean, think of a place like Ford. It's gigantic, right? And there's all kinds of parts of the car that people are working on at any given time. There's hundreds of vehicle programs going on at different stages.
Right.
And you're somehow going to turn all that into, a piece of automation that's going to run all that. And you could say, well, geez, in retrospect, that probably wasn't just going to happen overnight.
Right.
So that's part of it. The other part is, again, people underestimate the amount of soft stuff. We call it the soft stuff, the human side of implementing these technologies. It really is about change management. It's about process management. It's about who owns processes and who makes decisions about those processes. It's about how do you teach people? How do you overcome resistance to learning? How do you teach people when they're busy trying to do their day-to-day jobs and you're trying to train them in a new way of doing their jobs? That's all the stuff that you really get hung up on. And that's why it's taken so long. I think it reminds me a lot about enterprise resource planning back in the 90s as well, right? People just thought it was going to be a cakewalk. And it was just incredibly tough journey, partly because the technology was in some cases, the technology wasn't ready for the complexity of the task. But usually it was much more around people readiness and process readiness and the maturity of the companies to be able to handle it.
Yeah, I think the human factor is always the biggest hurdle, right? Because if you look at everything on paper, yes, of course it makes sense to implement PLM. It makes sense. It makes you more efficient. You work, but people are so resistant to it, which is, I think it's human nature, right?
Well, I remember there was a really good guy at Ford. We had a guy who was really our change management kind of guru. And he said something that always stuck with me. He said, Mike, people don't resist change. They deal with change every day. They resist being changed. And I thought that was really profound. I was like, yeah, that's really the issue, right? I mean, human beings are very flexible, right? We deal with all kinds of issues every day. While you're driving to work, right? There can be a different path you have to take. Somebody go around your car, et cetera. But it's being changed where the resistance comes up. And that's where you have to follow a process, really, a very people-oriented process to drive change in an organization. And we spend a lot of time talking to our customers about that because people get so hung up on, well, it's all about picking the tool and making sure the tool can do everything I want to do. And we go, you know what? These tools are going to do what you need them to do at this point. It's not 1990 anymore, 1995 anymore. It's 2023. The tools aren't going to be your problem anymore. The technology is more than capable of doing what you need it to do. Your problems are going to be around change, leadership, process management.
That makes a lot of sense. And if even with all of that, you look at the companies that are out there today doing amazing things. For example, just last year we saw SpaceX, Blue Origin, Virgin Galactic. I mean, these are privatized space launches, which is pretty amazing, right? And these companies are accomplishing these things at a much, much faster speed thought possible. So I imagine within these organizations, there has to be systematic changes and implementation of processes that allow them to do that, in much more quickly than anyone thought possible. What do you think some of the things that we can learn from those companies in terms of how they execute?
I think the first thing I'd watch the speed thing a bit, because SpaceX has been around for a long time. People don't realize, right? I think it's been a couple of decades now with SpaceX, right? So it took them a while to get to where they got to. And the same now, to your point, though, I mean, some of the newer companies like the Virgins and the Vias and all these smaller companies that are coming up, they are trying to operate on a much, much quicker time frame.
Yeah.
I think a couple things that we can learn is that certainly commercial aerospace is much less regulated than, the mil defense stuff.
Yeah.
And the NASA stuff, right? So now that could be a mistake. We won't know until we really start getting to a lot of launches, right? To see if people are cutting corners. But certainly, I know when I worked at NASA, you only use spaceflight qualified hardware, and it takes forever to get stuff spaceflight qualified. So, people think of NASA as cutting edge. It's really not. You have to use technology. It's usually 20 years old or so, because that's the only thing that's qualified for space.
Right.
So space is, you got vacuum, you got radiation, and all this other stuff. Whereas commercial aero, they're like, no, we're using the stuff that's available today off the shelf. And somewhere in the middle is probably the right answer, right? I think maybe NASA, and I think NASA's probably gotten better at this, right? Is that they're saying, look, we don't have to have stuff that's qualified from 20 years ago, but at the same time, we have to have a way to take the latest stuff and decide where we are on that curve of we can get away with using that in space, right?
Yeah.
So I think that's one thing we've learned. I think the other is that the technologies in some sense are more mature that these guys are using, right? So they are leveraging a lot of investment that NASA made over the decades, right? That they're using a lot of learnings and things. So I think that's the other thing, is it pays to stand on the shoulders of giants when you're trying to do this stuff, right? But then also, I think we're better now at organizing teams of people to work together. Like, well, first of all, the computers are better. So you have more power at your hands, right? NASA went to space, right? Again, with slide rules and paper. Right?
Yeah.
So, we're, in that sense, your design cycles can be shortened, or you can get more done in less time with the computing power. So I think that's another thing, is use the heck out of the computers. Then the other thing that's happened, I think, with software development is agile development and the use of sprint teams and scrums. Those techniques work beyond just software development. There's a reason why when you say, okay, we should think about smaller teams that are better trained, that work quickly, that think about how to chunk the work up into pieces that you can actually get to and measure and move and determine quickly if you're moving forward or not, and work in sort of tight cycles, as opposed to these sort of, all right, we'll spend months on the requirements, then we'll spend months on the analysis, then we'll spend months on the design, then we'll spend months on the build and test, then we'll spend months on, instead you're saying, well, how quickly can we get through design, requirements, analysis, design, build, and think about it more quick iterative loops. And again, leveraging computers and simulation to go faster.
Right. No, those are some great points. I mean, I think I read somewhere where the first launch to the moon, the computer technology was more primitive than a Nintendo gaming system back in the day. And we send people to the moon with that technology, right? So it's some pretty incredible things.
But yet we did it. I mean, think about it. Yeah. We've done the computers and all that. Yeah. I mean, but we did it.
And the big thing now too is a lot of these have been on a new, as a matter of fact, I just saw, I think it was a Honda commercial where at the end of the commercial, they show an eVTOL flying. So electric vehicle takeoff and landing. So now, we have autonomous vehicles, self-driving cars, but, eVTOL. this is Jetson stuff. This is stuff like we're growing up watching the Jetson and see flying cars and stuff. And people have been talking about these things for years. Oh yeah, one day we won't need road. Cars are going to be flying everywhere. I mean, we are getting there. This is very exciting. Do you think that's a good thing? I mean, I see a lot of people on the road. I don't know if they should be flying cars.
I think that's exactly the point, right? Yeah. I think sometimes the technology gets ahead of our ability to use it wisely. And that's always a tension that we have to manage. I don't have easy answers for how to do that or who should do it or when should do it. But I do know that it does need to be done or we get in a lot of trouble.
Yeah, no kidding. No kidding. Now, obviously products are getting more and more complex, and the approach and the methodologies we use to develop these products are getting more complex. Obviously, the requirement changes. You need more to handle more things. So that brings us back to model-based system engineering, which is one of your areas of expertise. For those uninitiated, what is model-based systems engineering?
So let's go back to what is systems engineering and what is a system, right? So a system is a collection of interrelated parts that actually achieve a mission that is beyond the capabilities of any one part, right? So if you take a car, right, a wheel can't can't get you from point A to point B by itself. The engine can't, right? It's all those pieces working together that create the car as a system to get you there. And systems engineering is the structured approach to build those kinds of systems. There's a tendency for people to say, hey, I want a car. I want to design a car, and the guy goes, okay, great. I'll just start working away, right? I'll start immediately. Okay, let me think. What does a chassis look like? Okay, I'll design a chassis. Then I'll think about what kind of engine. Well, wait, before you run off and start doing that stuff, you probably should think, well, wait, who's the car for? How many people is it going to carry? What kind of weather does it need to operate in? What kind of gas mileage does it need, right? What technologies are available that have to trade off to internal combustion engine versus battery, right? I mean, there's a bunch of things you probably should go through before you race off and start immediately hire a bunch of designers and start, designing parts. So, systems engineering is the process for doing that. And what people find is and this goes back to the 1950s and studies that have been done that show that if you don't do that work up front, you'll pay for it on the back end. And so they did tons of studies on this stuff. It came out of mil defense spending and stuff where they said, if we don't put this time in up front, then you're going to pay for it on the back end, where it's way more expensive. Because you find a mistake in manufacturing or in assembly, then to fix it, right, you got to go all the way back to the beginning, redesign, rebuild, redo, and it's better to do that stuff up front. So that's the system engineering process. It says you go structured approach from requirements, analysis, design, build, test, validate. And so given that it's been around since the 1950s, though, again, before computers or powerful computers, it's a very paper-based process. And these days, there's a few things that are a problem with that. One is that, first of all, paper is an imperfect medium to capture design intent, and transfer information. And like you said, the products have gotten a lot more complex, right? Back in the 50s, 60s, nobody was building 32-bit, 64-bit microprocessors into a car, let alone, think about it. A car has multiples of processors, right? If you think about it, right? So now you not only have sort of these mechanical hardware, you've got electrical hardware, you've got software, and all this has to work together. And so the idea that this is just going to get thrown together and work is just not going to, it doesn't happen. And trying to manage that with paper is incredibly difficult. So where model-based system engineering comes in to say, well, hey, let's leverage the computers. Let's leverage these models that we can build using computer tools, and then use those to drive the system engineering process instead of all this paper. That's effectively what it is.
Yeah, I mean, and going back to the discussion we had earlier about PLM and PDM, there's also resistance, right, from implementation of MBSE, especially from a lot of users and people who operates within that system, right?
Yeah. So there's usually a couple pushbacks. First pushback is on system engineering. It just doesn't click with a lot of people, right? They go, well, I want to get started. And you go, well, what are your requirements? Let's do it. And they go, no, I don't want to hear that stuff. Just get going, right?
Just
so there's just a bias against system engineering and people who practice system engineering in real life. I remember a long time ago, I was talking to a guy at Chrysler, this was before I worked for Ford. I was like, I think car companies could really benefit from using more systems engineering, having come from places like NASA and stuff. And the guy was like, what are you talking about? We have systems engineers. And I said, well, like what? And he said, brake systems. And I was like, oh, okay. And I got it. Like, that's their view. It's like, the subsystem is the system. It's like, no, you need someone with a complete end-to-end view of the system. So that's one pushback. And then to your point, the people that are using systems engineering, there has been, I think it's going away now, but say 20 years ago, there's a pushback around model-based system engineering. Because like, well, I do system engineering. Here's all my documents, right? Here's my traceability matrix. And now I got to learn a tool, and the tool is only going to do part of it and all that. So you got all that, and was the technology ready? So you got all that pushback that was around. Now I got to learn a different way of working, and are the tools ready? So I think that's where the push, like you said, there has been pushback on that. My sense is that it's starting to go away, though, because to your point, right, all these companies that are starting to do all the commercial aerospace company stuff, they're trying to get stuff done very quickly. And again, you can kid yourself. You think you're going fast, and you get to the end and something's not right, and you realize you should have done more work up front. So all these companies are basically saying, yes, we need system engineering. And by the way, we can't use that old document-based approach. We're going to have to use something that's computer model-based, and that gets them right into model-based systems engineering.
Right. No, you're exactly right. You did a webinar recently on model-based systems engineering. And by the way, that's available on our YouTube channel. So you want to go check it out. And 3 of your key takeaways were process first, not tools. Look for business value and demonstrate benefits early. Can you expand on those 3 key takeaways?
Sure. And this goes right back to the change management being the key to this whole thing, right? That's where your success is going to be. And so those bullet points, those takeaways really came from that. So, what's your burning platform, right? What is the benefit that you're really trying to achieve? Does everybody understand it? Because if people don't see that, if they think everything is fine, right? Again, people don't resist change; they resist being changed. So if they're going to resist being changed unless they actually have a pain that they're going to get resolved in this thing, right?
Right.
And then when it comes to it, you say, okay, well then I need to have a path to get there. And what we've learned over the years is that the path to get there isn't what tool you're using. It's what are the processes that you're changing, right? What is it that you're trying to achieve as a business, and specifically your business processes that you're going to do differently. And you have to do that work before you start worrying about what tools. Everybody goes straight to the tools. That's the easy part, right? That's the fun part. It's the visible part. The hard part is really having those tough discussions around what does our engineering process look like and how does it need to change to facilitate this future a vision that we're trying to get to. Then the last piece, again, is from change management lessons, is that people that have started down these journeys that are going to take 3, 4, 5 years, right, to really do PLM. It's almost a decade journey.
Yeah.
But the problem is you can't say, okay, we're going to put in all this work. It's going to be nothing but pain and anguish and cost. And then in the 9th year, we'll see benefit. Forget it. You're just going to fail. So the lesson learned from change management is you have to have some early wins. You'd really want them to be in the 6-month time frame, ideally.
Right.
Shorter if you can do it. At the longest, maybe a year. So you can point to people and say, "Who?" Again, you're just imagine, right? You're pulling. There's a journey, right? And there are going to be ups and downs, like a valley. I mean, those analogies fit perfectly, right? You're going on this long journey. There's going to be deserts. There's going to be oceans. There's going to be you're going to have to build boats. You're going to have to cross the ocean, right? And to do all that, people have to have something keeping going. Well, you've got that spur, right? It's like, hey, if we stay where we are, we're going to be we're toast. So we have to move forward, right? That's one. And then 2 is, we see that we're getting there step by step, right? It's like, oh, good. Today I couldn't do this. Now, before I couldn't do this, now I can. And that's a benefit for me. Now I'm interested in taking the next step on the journey and then next step. So that's the other part, is getting those quick wins in is critical.
That's awesome. Wow. I can't believe we've been talking for almost half an hour. Such an interesting conversation and subject, but I know you're a very, very busy person. So I think we will have to expand on this topic and maybe
anytime. Yeah,
have you come back and talk about other
Yeah.
things.
Yeah, that'd be terrific. No, this has been fun. And like I said, I enjoy talking about system engineering and model-based system engineering. I love talking about all the ways Saratech can help people with those kinds of journeys, even the journeys of just using their CAD and PLM tools better, right? I mean, there are plenty of people who aren't getting the most out of the tools they've got before they can worry about a long, complicated journey to some far-off vision of pure digital nirvana. There's plenty of stuff that people can do today to get more out of the tools they have. Again, with that mindset of quick wins and getting people excited and energized about doing the stuff that's going to take longer to do.
That's fantastic. Really, again, thank you so much
for
being
Andy.
on our podcast
terrific.
today. I really appreciate your time. I know you're a very busy person, so I appreciate you taking the time to join us today. And I got a lot out of it. I hope our audience will too, and I'm sure they do. A lot of useful information. And again, thanks for joining us, and we'll talk to you soon.